we are going to show that for these two given symmetric matrices, the inverse or their inverses are also symmetric. Again, these two inverses are symmetric because of the main diagonal. We have here we have the same entries of the main diagonal. This is also true with here. You have -2, -2, -7, -7, 3, and 3. Or, in other words, they are considered to be symmetric because their transpose is equal to the matrix itself. But here, we're not talking about the transpose. We are to show that the inverse after a series of processes is also symmetric. Now we have 2 by 2 matrix and 3 by 3 matrix. We have separate process for this. Let's start with 2 by 2. For 2 by 2 matrices, we're just going to use this formula for solving the inverse of a 2 by 2 matrix. Its inverse is equal to 1 over the determinant AD minus BC times, if this is A, this becomes A here, this is D, this becomes our D minus B minus C. That's the process of getting the inverse for a 2 by 2 matrix. So our A is 2, B is -1, C is -1, and D is 3. So we can solve first for this expression, which is actually the determinant. We have 2 times 3 minus -1 times -1. We'll have 6 minus 1. Our AD minus B is positive 5. Okay, so applying that, we have a lot of spaces here. Don't need to worry. You will have here 1 over 5 times. You now interchange D. This is now 3. This is now your 2. So negative of -1 is positive. Positive here as well. So our result here for our inverse is we have this matrix 3/5, 1/5, 1/5, and 2/5. This is now the inverse of this first matrix, which is a 2 by 2 matrix A. And notice what happens to our inverse. Of the main diagonal, we have the same values here. So this means we have shown that A inverse, or the inverse of A, is also symmetric. So we have shown that for 2 by 2 matrices, we have shown that they are, we have returned to symmetric matrices. Now, let's proceed to our 3 by 3 matrix and show that its inverse is also symmetric. But here, we cannot use this formula, but this is for 2 by 2 matrix. What we could do here is to use an adjoint matrix where we show here that from A and pair it with an identity, it will result later on to identity and its inverse. That's our process here. So for this, we have here, so we have a lot of space at the bottom, don't need to worry. 1, -2, 3, -2, 1, -7, 3, -7, 4. And then you have here identity 1, 0, 0. So the identity must be the same size. Okay. We are going to apply elementary row operations to this and reduce it to a reduced row echelon form, or return to an identity. And what happens here would be your inverse of A. And let's check later if that is actually symmetric or not. So we have here multiple processes before we could determine whether the inverse is symmetric or not. So what we could do here is this. So please follow. Since it's the leading or the first entry for the first row is leading 1, so we don't need to divide all entries by something. What we could do here is multiply 2 to row 1 and add to row 2 for this to become 0. That will be our new row 2. And we're also going to multiply -3 to row 1 and add it to row 3 for this to become 0, and make it as the entire row 3. Do the same thing for this here entries. So you will have 1, negative 2, 3. So for the second, 1, 0, 0 here. So 2 plus 1 is, or the other, 2 times 1 is positive 2 plus negative 2 is 0. 2 times negative 2 is negative 4 plus 1, you'll have negative 3. 2 times 3 is 6 plus negative 7 is negative 1. Let me do it again. 2 times negative 2 is negative 4, negative 3. 2 times 2 times 3 rather is 6, negative 1. Do the same thing here. 2 times 1 is 2 plus 0, 2. 2 times 0, still 1, is still 0. For the third row, negative 3 times 1 is negative 3 plus 3, 0. Negative 3 times 2 is positive 6 times negative 7, plus negative 7 is negative 1. Then we have negative 3 times 3 is negative 9 plus 4 is negative 5. So do the same thing here. Negative 3 times 1 is negative 3. So it's still 0. It's still 1 here. Let's move further. You can always interchange rows if you would like to. Let me interchange row, or yeah, let me interchange row 2 and row 3, so that we will have a better coefficient to be manipulated. 1, 3, 1, 1, 2, 1, negative 2, 3, 1, 0, 0. This becomes 0, negative 1, negative 5, negative 3, 0, 1. And I have here 0, negative 3, negative 1, 2, 1, 0. Then I'm going to multiply negative 1 to row 2 to become the new row 2. And I'm going to multiply negative 3 to row 2, not the new row 2, but the same row 2 here, plus row 3 for a new row 3 for this to become 0. So move. We have 1, negative 2, 3, still 1, 0, 0, then 0. Sorry, that's positive 1 now, positive 5, positive 3, 0, negative 1. And then we will apply negative 3 here. Okay, it's a 0, so positive 3, positive 3. So negative 3 times negative 1 is positive 3 plus negative 3 is 0. Negative 3 times negative 5 is positive 15 plus this one here. So you'll have positive 15 minus 1, so you have 14. Negative 3 times negative 3 is positive 9 plus 2. Positive 9 plus 2, you have 11. Then you have negative 3 times 0, this is 1. This negative 3 plus 0, so negative 3. Now, I would like you to multiply 1 over 14 rather, to all the entries of row 3 to become row 3, so that this will become 1. And we will now achieve a row echelon form, but we are not yet done. Okay? So we have 1, negative 2, 3, 1, 0, 0. So you will have here 0, 1, 5, 3, 0, negative 1, 0, 0, 1 now, 11 over 14, 1 over 14, negative 3 over 14. Next is to make these two zeros here. I do hope that you are okay with handling fractions. So you have negative 5 times row 3 plus row 2 to become the new row 2. And negative 3 times row 3 plus row 1 become our new row 1. Okay? So 0, 0, 1 still, 11, 14, 1 over 14, that's 14, and negative 3 over 14. So negative 3, there's still 0 here, there's still 1, negative 5 times this, So that's negative 5, so 0 here. Negative 55 over 14. 13, 3 times 14 is equal to 42, negative 55, and then you have 42 is negative, again, negative 15, right? Sorry, not, my bad. Negative 55 over 14, negative 55, so you have negative 13 over 14 here. So from here, you have negative 5 over 14 as well. So negative 5 times negative 3 is negative 15, 14s. Then you have minus 1, which is 14, so you have positive 1 over 14. Now for the first row, negative 3. So this is still 1 here. This is still negative 2. So negative 3 times 1 is negative 3, sorry. And then plus 3 is 0. What happens to the next would be negative 3 times this is negative 33 over 14. And then you have 1. So negative 33, then you have positive 14. So you have negative 19 over, that's 19 over 14, right? Next, we have negative 3. So that's 3 over 14. So negative 3 over 14. Then negative 3 times negative 3 is 9 over 14. So you have 9 over 14. So let's hope that we could really get a symmetric. Or if let's really hope that the processes are all correct. So to remove this now, we're going to multiply 2 to our row 2 and add it to row 1 for a new row 1. So that here, this is 0, 0, 1. This is 0, 1, 0. In short, this is still 11 over 14, 1 over 14, negative 3 over 14, negative 13 over 14, negative 5 over 14, and then you have 1 over 14, but this is still 1. 2 times 1 is 2 plus negative 2 is 0. Okay? So we already completed this one here to become identity, and let's find out what is the inverse on the other side, and hopefully this is symmetric. 2 times 13 is 20, negative 26 over 14. Next, 2 times negative 5 is negative 10 here, and then negative 3 is negative 13 over, that's negative 13 over 14. And finally, 2 times 1 over 14 is 2 over 14 plus 9, 11 over 14. Let's check if this is really symmetric, or let's just try to rewrite it here. So the inverse of A, so you have negative 26 over 14. A little bit spaces. Yeah, let's have a little bit bigger. Yeah. So you have negative 26 over 14. Negative 13 over 14. 11 over 14. This is for the first row. Second row, negative 13 over 14. Negative 5 over 14. 1 over 14. Next, 11 over 14. 1 over 14. Negative 3 over 14. Along the main diagonal, see if it's symmetric. Negative 13, negative 13, 1, 1, 11, 11. Finally, we have reached an inverse of the 3 by 3 given 3 by 3 matrix. And we have shown that here, A sub 1, the inverse of A, rather, is symmetric as well. So we are done now with these two methods. Of course, the first method is shorter as it is involving 2 by 2 matrix. But for 3 by 3 and for more square matrix like 4 by 4 and 5 by 5, we'll be using this method. and then we're going to aim for an inverse the given using the row operations that will result from your identity here. This is for this video. Thank you very much for watching.